Hi, you are welcome in the online learning in PG program in GIS and remote sensing, which is running under the Department of Geography and Environmental Studies, College of Social Science and Humanities in Adigrat University. So in this slide, we'll discuss about the data analysis in GIS. So under this course, we will learn three major topics. The first one is site suitability analysis. In site suitability analysis, we will learn about we are having some task like we have to find the most suitable place to establish a school or something, to establish a tower, communication tower. We have to we have to search a suitable site to open a market. So this tool is very good for analyze this type of the the information or data, and we can find the suitable site based on the criteria. The second one is network analysis. Under network analysis, as the name indicate network, there may be a network of roads, there may be network of railway line, network of the canal or another linear feature. So based on this data we can find this the best route. Like if we have to go from one place to another place, then which will be the most suitable route to go from one place to another place. Under geostatistical analysis, we will learn about the as name indicate, geostatistics means if we have the data, point data or polygon data, with that data we can uh, explore the statistics of the data, how the data is distributed, how data is normal distributed, how data is skewed, and there are another things like kurtosis. So such type of things are can be done with the help of geostatistical analysis tool. And under geostatistical, another like we can create the surface based on our known values. If we have the point data, so point data will give you the measured or observed location. Based on measured values, we can predict the values of another place and we can create the raster surface. Under geostatistical analysis, we can find the pattern also. And this pattern is very important for geography students because if they are doing any research, then they must know that what is the pattern of the of anything. Like if there is a disease, so you have the disease data, how many people are suffering from this disease at this point, another point, and another points. So by geostatistical analysis, you can search whether this pattern is random or clustered or dispersed. So all these topics are very interesting and we will learn one by one. So let's begin with the first topic, that is the site suitability analysis. So under site suitability analysis, you have to go through step by step. First of all, we will learn that what is site suitability analysis, and the second point will take you to the natural six steps right from the step one. That first of all we have to think that what is the problem, and thereafter step two we will break down the problem. Step three we will explore the input data set. Here step 3 will take you to the software site where you will take the data which is required to solve that problem, and the step 4 will give you an idea of how we can perform the analysis, and step 5 is whatever result will come, we have to verify that result, and thereafter that result should be implemented if it is verified that it is correct. So here, what is the site suitability analysis? Site suitability analysis is just to identify the best place for something, the best place where your cost will be less, and whatever you are doing, it will be the best place for that work. And it may be anything. Here are some examples given, like where you can start a new housing development. So that place, how it is suitable for housing development, how far it is from the road, and how it can be closer to the market, and so on and so forth. And another examples like wildlife habitat areas based on some parameters, maybe what are the requirements of wildlife and what is the purpose of such kind of area development. So if data is there, then you can identify which location is suitable for wildlife habitat area. It can be done for optimum routes also. And like there are another thing, for an example, like if you have to develop a school, primary school, then which is the best place to develop a school? So in this exercise, means we will take an exercise like if in Adigrat town we have to establish a school, then how we can analyze or how we can find the suitable site for a school development in Adigrat town. The second point is the conceptual model, how we will proceed, where is the beginning and where is the end. So from beginning to end there are 6 steps. So we will discuss all these 6 steps one by one. The first step is stating the problem. As we can understand that we are learning all these things under geography, under GIS. So if there is any problem, like we have to look at the place where the most suitable place for new school, then of course we need a map. So the first map may be the general map of the suitable locations. There may be more than one location. And the second map, which we will require the specific location based on the general suitability map. So there are 2 maps. The first is general suitability map, and the second one is a specific suitable site for the development of the school. So the second step is we have to break down the problem. And in the first step, as we have decided that we have to establish a school, so what are the requirement means from the viewpoint of information needed to us, that what are the factors affecting the school, the location of the school. So we have to break down all the problem. And here you can understand that if you have to search a best area for a new location, then you should know the land use type. You should know the slope. Of course, the steep slopes are not suitable for the development of a school. So that is also very important factor. Third one is your school should be near to the place which have like ground, open space, or it may be a recreational facility. So, and the last one may be like you will not develop your school near another school. So your school should be in that area where there is no school. So these are the 3 4 type of data which you have to keep in your mind in the second step. So to meet the objectives, you want to know the following things. The first one is land use in this location of suitable type. What is the land use and land class? Where are location with relatively flat land? Are these locations close enough to recreational sites? And the last uh, is is there a place which is enough away from the existing schools? As you can see, the first one is the land use. What will be the input? Input will be the land use data. So the land use data will give you an idea of different type of land use. Uh, it may be barren land, it may be the built up area, it may be administrative area, it may be a forest. So if there is a rule that there will be no construction in the forest area, so you have to restrict that area in your analysis. If there is a rule that okay, the barren land is fine, you can develop your school there, then you have to give more weightage to the barren land areas rather than commercial area, because commercial area, if you will give more weight, then it may be very costly to construct a school in the center of the town or commercial area. So the first input data set which we need is the land use data. The second one is the elevation. Elevation, you can derive from elevation data the slope map. The slope may be steeper, it may be lower. If it is above 30° by government rule, it may not be allowed to construct anything. If it is above 30, then you will restrict that area. And the school should be relatively on flat land. Then you can develop different classes, and like if the slope is 0 to 5, then you can give more weightage to that class. So the last two uh, types of data required will be the input data set, like recreational site. Where are the recreational site? We are here calling recreational site. It may be like the sites where the open land is available or green space is available. And the fourth is the data of existing schools. So uh, total four data you will need for analysis. The first one will be the land use map. The second one is elevation or slope map. The third one is the location of recreational site, and the fourth one is existing school. So as step three, you can explore the input data set. You can think more about the input data set. There are four data sets which are required for your analysis. So you can think of that, okay, if this is elevation data, then how much important it is. If it is land use data set, that what type of land uses are required, which will influence your analysis. I mean, the problem is we have to find the suitable site for the construction for a school. Then what type of the land use data is suitable for that. So you can uh, think of and you can explore the input data set here. So here in this step 4, we have to start our performance. But before that, you have to think this image given. The definite goal is we have to locate a school. What are the criteria? There are four criteria. Based on four criteria, the first one is land use, second elevation or slope, third is recreational site, and the existing schools. So there are how many criteria? Four criteria are there. So we will use all this data, and we will drive the data. Okay, using this data, we will drive the data, then we will transform the data, then we will give the weight here. After giving the weight, we will run, and the GIS software will give us the location. It can give us an area. Okay, we have to find from that area the suitable location. So far we know that we are using four types of data. So here my software is already open. First of all, what I will do, I will take the data. There are four types of data which we have already mentioned. And the first one is the land use of Adigrat here. Okay. The second one is the dam data of Adigrat. Okay. The third is the green area side. Here, green areas I'm taking like the recreational sites. Right? And the last one is the location of primary schools, existing primary schools. So all this data is here. This is location of primary schools, and this is the location of green areas, and this is the land use map, and here this is the dam. So as we know that we have the four inputs, and what we will do first, we will give the ranks, and for giving the ranks we will use the reclassify tool. Okay, then here we will go for some data processing. Before that, few important points. Number one is the site suitability analysis. It works with raster data. So before that, what we'll do, we will prepare our data, because here two data sets are given in the vector format. You can see primary schools and green areas. So we will convert it into means raster form. And before processing, before combining all these parameters, we should remember that we have to give some similar characteristics like the cell size, the extent, so and the classes. So let's do that. But here you can see this is the dam here. But here we are using slope as a parameter. So what we will do, we'll convert it into slope, and the extent will keep it like this, the extent of land use. So let's do it. 3D raster surface, then slope. For slope, here is the dam. Okay, degree is fine, and just to make it at the extent of land use, we can go for processing extent here, similar to land use. Okay, similar to land use. Okay, done it. So we have got our slope also. Now this dam is not required here because we have already taken the slope. Okay, fine. Slope here, this is here. So this vector data, green area and primary schools, will make the raster surface for this data also. And as we are doing this exercise for land suitability analysis, so this thing is very important when we are analyzing suitability. Then the distance will matter here, okay, especially in case of distance from the primary school and distance from the green areas. So distance is very important for these two parameters. So for that we will go to spatial analysis tool. Thereafter we'll go to distance. Here there are different types of distances, but here we are taking Euclidean distance, simple one. And if you want to more you want to know more about this one, you can go to tool help here. So let's do it. Primary schools, so the distance, the cell size, we can make it 30. Okay, and this is what primary school distance. So distance is here, we can rename it here itself, primary school. This is the distance, primary school. Okay, maybe the name is already given there. So this is what distance of primary school. Okay, but I think I should give the extent similar to the land use. So let's do it again. Euclidean distance, the distance primary school, cell size we can make it 30, and the processing extent we can make like similar to land use. Okay, Let's do it. When you are doing your work, remember one thing, that you should change the name. So because another data is also there, it can make you confused for that. So here this is distance primary school. Okay, so you have done it. Thereafter we'll take the distance from green areas. Green areas distance. Let's make it 30. And the environment, we can give the similar processing extent. Land use maybe. Okay. So this is the distance from distance from the green areas. So once you have done it, better you can remove, because it will make you. So distance from green areas, distance from primary school, this is slope, and this is the land use. You have done it. Okay. So as you can see here, the values are there, like the distance 621 from 0 to 621. So these distances you have to give some weight. For instance, if this is the distance from green area, if distance is increasing from green area, it is not good for your school. Then you will give high weightage to that distance which is nearest. So for doing this, you have to go spatial analyst, then reclass, and you will use the reclassify tool. And let's see distance. What is this distance from green area? So the closest distance value is given 1, but here we will give higher value. Okay, so let's see here total number of classes are, but in the model there you will see the minimum 0 to 9. So what we can do is we can classify it into 9 category here in place of 10, 9. Okay, and thereafter this is reclass. So if it is closer, value is given 1, it should be higher. So you can reverse to the new values, just reverse. So the older value, if it is near 9. Okay, here you can change it like this is green area distance. So here 9, you can see here coming the core area, this is 9, after that this is 8, this is 7. So it makes this sense that as you are moving away from the green areas, the value is decreasing here. We have done it for green area. Thereafter we'll do it for okay, we'll do it for the primary school. So for primary school, the closest value is 1, and if it is far, the value is more. So here also we should give the similar class. Earlier we have given to 9, so here we will do it 9. Okay, and this is what? This is primary school distance. So 9th is given to the, if it is very far, if it is far from the existing school, then you can see here 9 value is given to the very far area. Okay, so we have done it primary school distance, and this is for green area distance. Then the slope also we can classify into 9 category. Each category will have its own. So take the slope here, and we will classify it into here. Nine classes are there. Okay, good. So if it is flat, value is 1. We have to reverse it, because if slope is less, we'll give higher weightage. Reverse it, and this is what? Slope reclass. Okay, so this is the reclass of the slope. Means the 9th one is very important, so we have given it 9th. Relative flat is 9. So slope is also done. Thereafter this data is ready for yeah, here also we can give some weightage to each class, like okay, administration, here it is given 0. Fine. Service area, okay, 1. Transport, 1. Recreational, and okay, so for recreational is important, so we can give some higher value here maybe, and this thing we can do later on also. Residential area is 8 here, we can give it maybe 7. Commercial, because it will give you higher cost, so you can give it less. Manufacturing is not good for schools. Manufacturing area, you can give lesser weight here. Recreational is fine, you can give 7 here. Transportation 2 is fine. Recreational, okay, so we can make it okay here. Fine. So just we will take this land use classes here. Okay. Now we have the data. So we have the slope data. We have the distance from the primary schools. We have the distance from the green area, and we have this land use. Now we have to combine all these parameters. This is our land use, and this is the slope. Okay, distance from the school and green area. So for this very purpose, we can do with this model here, and we have the land use. We have the slope reclass. We have distance from the schools. We have distance from the green areas. So what we will do is we will take the tool for that. That is overlay tool. Yeah, overlay and weighted overlay here. You can see here by double clicking. Here you have to give the rasters. Okay, here you have to give the influence. Here you can give the scales also. So connect it with the tool. And now you can see here, you can minimize. You have these four data here. One is land use, second slope, third distance from primary school, and fourth is distance from green areas. So here the influence, you have to set the influence. How much land use is influencing? So here you can change, maybe land use is influencing important. This is important. You can make it 50. Thereafter, because white is red, it should be 100. Slope, you can say it is maybe 20% influence. Distance from the schools, make it 20 maybe. Or green area distance, you can make it 20 here. So the land use, you can say make it 40%. Okay. So this is the influence you have given. The sum of the influence is 100 here. Thereafter, you can make some scales. Okay, this is the land use here, and this land use is divided into 9 classes. So it was better if you, okay, let's see these 9 classes, because name will, it's not there, so we can see. Okay, we can see the what are the land use classes. Okay, let me take this snap. It will help me. So here these are the 9 classes. Value, the first is administration. Administration field value is this, skill value means 9. If value is higher, means you are giving higher weight. So residential area, you can think and you can prepare for this. Residential area, here this is for exercise only. So you can give your own widths. Residence area is 9, but residence area we can make like maybe 6, okay. Special functions, make it maybe 6, something like this. Urban agriculture, it is important, so we can give less weight because this land is important for agriculture. Commercial area is number 6. So commercial area is not good because here cost will be higher. We can make it 4. Then the 5th category is manufacturing and storages. Oh, is if something you want like manufacturing area is not good because it may make noise or something. So you can restrict also, okay? It will not give you. So you can restrict this area. Means the model will not take the manufacturing area into analysis. It will restrict. It will make a blackout that area. So this is 5th, and 4th is recreational environment. Then you think, oh, this is important for my students. You can make it 8. And the 3rd is transport. Oh, this you can restrict. Yeah, already constructed there. And the service areas you can make it 2. You have already done it. Then 1. So this is only for the randomly I have given the scales here. So I have done it for land use. Slope reclass, as you can see that we have already done it. The higher values are given to relatively flat area, so no need to change it. Distance from primary school also higher values are given to that area which is far from the primary schools, okay. And the same is here. So once you have done it, then you can apply, then you can make it okay. So before you run your model, what you can do is you can make it add to display, because when you will run it will add here. And now you can plus run it, okay. So your result is right here. And as you can see here, the manufacturing area you have you have restricted that area, so it is making it 0, okay. Means it is giving you 0 here, okay. This is restricted area. So all this is the manufacturing. I have restricted the transportation also, so this all black is restricted area, okay. And the 7th one is the area which is most suitable for the construction of the school, okay, which is this area, the 7th one, okay. The 6th is means this is something which is for the practice only. You can modify your model again and again, and you can save your model here, and thereafter you can modify these values, okay. And you can change, because if you are modifying anything like restricted here, suppose no, now I have changed my mind, I will take it 1, I will not restrict, or I can make it 3. Okay, I will apply it. Then thereafter, before running the model, because this is already there now, you can make it 2 for second one. Apply. Okay, and uh, again you can run your model. So run it. So it will give you some another result. Now your restricted area has been reduced. Okay, now it has been reduced. Before it was more, now it is less, because I have said, okay, transportation I'm not restricting, I am giving another value. So this is your model, and here you can save your model also, just to use it for another. How you can save? Whatever folder you are giving, in that folder, first of all, this model can be saved within the toolbox. So you have to take a toolbox, suitability analysis, and under suitability analysis you can give like school model. Okay, save, and here if you are closing it, no problem, and you can take your model from there. You can open your model from that location, and you can save it here as a tool also, like add toolbox, maybe T. It was in PP, I think. Yeah. Suitability analysis. I have taken the suitability analysis. This is suitability analysis, and this is your model. You can edit here, and thereafter, if you want to give another parameter, then just to you can take the layer, and that layer you can prepare as per the other layers, and thereafter you can add that layer to this tool. So this is the way we can find the suitable areas. So all these are, the seventh one here. The seventh one is the most suitable areas here, as per the given parameters. As you can see, these areas are the most suitable. Red one. Okay. So from red areas, you can conduct a survey, and you can search within this area. No need to go all throughout the town. Just you can focus on these red areas, and you can search the best location for the construction of the schools. So you have completed 4 steps, and under the step 4, you have identified the area which is most suitable for the construction of a school. Out of that area, you can find further, you can verify the result, and after verifying the result, if your results are fine, because that exercise I did by giving a random scale or something weightage, you can modify the weight, you can modify the scale, and again you can run the model by changing the output result name, and you can find the most suitable place for anything. It may be the suitable place for another, like suitable site for solid waste management, something planned solid waste management plan, where solid waste plant should be there. It should be far from the core of the city or far from the schools. And there are another parameters which you can search on. So uh, under step 5, you will verify your results. If your results are fine, there is no problem, then you can move on to step 6 and you can implement your results. So this was all about the site suitability analysis, how this overlay weighted model works, weighted overlay model works, that you can go in ArcGIS help part, and we'll discuss that in another section. Thank you very much.